First numerical which is assigned to us is page 296, question numerical number 1. It is a little bit complicated than the rest of the numericals. Over here it is stated that at what height from Earth's surface your weight will become 1/2 of your original weight on the Earth's surface. So then it is stated that use Earth radius as a unit. So what we have to do over here is that we will bring both of the formulas equal to each other. For example, we know that F is equal to mg, and we also know that F is equal to g m over r e square. Over here g is gravitational, universal gravitation constant. It has a constant value, and capital M is for the mass of Earth, and then small m is the mass of the person, or in this case it is mass of you. So comparing these both formulas, we will get mg is equal to g m over r e square. Then there is a condition that this mass, this weight become half. So we will divide both of the sides with by 2, which will convert it to half. So this is the mass, this is the weight which is required, and we have to, because we have to do it in terms of RE, so we will take an under root and we will take a square of RE, the two law which is toward the left side of RE, and by taking its square and under root we can take it common with RE, and then it will become under root 2 RE, and as a whole it will be a square. So this is the factor of RE, that by that factor RE will increase. So under root 2 is equal to 1.41. And now if we want to get the altitude, we know that 1 r is 1 RE, I mean radius of Earth, is the distance from up to the Earth's surface from the center of Earth. We can subtract that, and then we will get the distance from the surface to the height where the mass, where the weight would become half. So 1.41 RE minus 1 RE will give us 0.41 times radius of Earth, which will be the altitude, because altitude is from the surface of Earth to some height. So it will be 0.41, and that's it. And now in second numerical, it is relatively simple. In a hydrogen atom, a proton and electrons are that meter apart, 5.3 × 10⁻⁻11. So this is a radius, or you can say that it is the distance between the objects. So it will be defined by r. Distance can calculate the magnitude of gravitational acceleration. They are asking to calculate the gravity over here, and the mass of proton is given and the mass of electron is given. So what we have to do is basically we have to, as we have m1, m2, I am not writing them again over here, but we have mass of electron and mass of proton as m1 and m2, and the distance between them is r, which is also given, and then we just have to put the values over here, and whatever answer we will get will be the answer of this topic, this numerical. And that's it. So now we will move on to the third one. Two objects are distance apart, and then this distance increased by factor of 4. Okay, so in this question, in third one, it is stated that it is done over here. So it is written over here, the fourth one. Is it fourth or is it third? It is third one. the distance increases by a factor of 4, so r is equal to 4r, and we know that by universal gravitational law we know that r is reciprocal to the force, or is it inversely, and it is inversely related to force. So if r will increase, force will decrease. This is the answer for part A. Now by what factor it will increase or decrease, we have to put the values. The new force will become F prime, which will be equal to G m1 m2 over 4r. Instead of r we will write 4r. Then we will take square of this term. 4r will become 16r, because 4 times 4 is equal to 16, and the factor by which this is changed is 1 by 16, because this is the original value and this is 1 by 16 is the factor by which force is changed. So this will be the answer for part B, that by 1 by 16 times it will change. So it will reduce 16 times when distance will increase 4 times, and that's it. Now we will move to the fifth question. Okay, over here in third question, there are two masses which are some distance apart, which we call is r distance. Then we keep then we move them apart or move them away from each other in such a way that the distance will become 4r instead of r. We increase their distance between them 4 times. And then in part A they are asking, will it increase or decrease, what the gravitational force will increase or decrease by doing this. And in question B they are asking by what factor the gravitational force between the object will change. So you got the question? Okay, so now or when we know the universal gravitational law states that F is equal to G m1 m2 over r square, and r is in inverse relation to the force. Distance is inverse relation to the force, so we know that if the distance will increase, force will reduce. So this is the answer for part A, because it is inversely proportional, so force will decrease as a result of increasing r. So you got the first part. Okay, now we will move to yes, we just have to explain the original equation, that when the radius will, it is not radius, it is the distance which is denoted by r. The distance between objects will increase as it is inversely proportional to the force, so increasing the distance will decrease the force, and that's it. So this is part A. We have to tell that this force will decrease. Now moving to part B of the same question, by what factor it will change. So F prime is the change force is equal to G m1 m2 over 4r square, because it is increased by 4 factor of 4. So F is r is 4r now. So when we will put 4r square, then we can separate 4 from the r by taking its square, so it will be 16. So over here the rest of equation is same, G m1 m2 over r square is same, only the factor 1 by 16 is extra over here. So this we will conclude that the force will change by a factor of 1 by 16, and this will be the answer of second part. Now you got it. Because we are increasing radius 4 times and we are putting r as 4r square, and when we will take square of 4 we will get 16. Now in question number 5, we have a moon of Saturn which is Titan, and on the surface of Titan the strength of my gravitational field is 1.3 Newton per kilogram. Actually, the gravitational field strength is a synonym name of gravity. If you say gravitational field strength, it is just another name for the gravity, which we get from this formula, universal gravitational law. So we have the distance from the center of the Titan to the surface of Titan, which is, no, we do not have distance. They want us to find the distance or the radius of the Titan. The mass is given. So what we have to do is we have to simply apply the universal gravitational law, which is Fg is equal to g m1 m2 over r square. And now if we put F is equal to ma or mg, we know that g will become F divided by m. So for doing this, we will bring one mass, which is unit mass, toward the left side. So it will become F of g divided by m2 is equal to g m over r square. As we know that this F of g by m2 is equal to g, the gravity on Earth on Titan surface, so it is 1.3 Newton per kilogram. Then we can put the rest of the values. For example, we have the gravitational constant, which is 6.67 into 10 to the power minus 11. Then mass is given as well, so it is 1.3 multiplied 10 to the power 23. Then we can rearrange this equation for r. Uh, 1.3 is given in the equation, given in the question statement of the question, that this is the gravitational field strength, or you can say this is the gravity of the Titan, because this equal to force per kilogram, and this is equal to force divided by mass. We know that constant g is equal to 6.67 into 10 to the power minus 11. M2 is actually included in the value of gravitational field strength because it is equal to force per m2. So F divided by m2 is already given. M2 is not given as a separate, it is given in terms of unit mass, which is 1 kilogram, because over here it is written that on Titan moon it is the gravitational field strength has a magnitude of 1.3 Newton per kilogram. So it means that force 1.2 Newton is given for 1 kilogram of mass. So M2 is 1 kilogram and force is 1.3 Newton. Or you can say that Fg by M2 is 1.3. This is how we call it as gravitational free strength. Gravitational free strength is equal to G, which is equal to Fg by M2. This is the definition of gravitational field strength. And M1 is the mass of the Titan. And then we can simply get value of R by simplifying this. You got it? Then in 7th question, calculate the gravitational field strength. Okay, again the same thing is asked which was asked in previous question. We have to calculate G, and it will be F of G by M2. And then radius of the sun is given. For sun, we must have to know, or we need to memorize it, that for sun the mass of sun is 2 into 10 to the power 30. It is approximately 2 into 10 to the power 30. It will exactly, I think, 1.9 something into 10 to the power 30, but we can round it off as 2. And then we have to simply sub this into the formula. For example, F over M is equal to G M over R, and then F over M is equals to the gravitational field strength, which we have to find, and then G is the universal constant of gravitation. M, mass of the sun, is what we have to put by ourselves. It will be 2 into 10 to the power 30. Then R is given, which is 1.5 into 10 to the power 11, and then we will get 5.9 into 10 to the power 3 Newton per kilogram. 5900 is the gravity of sun. You got it? The 2.0 2 multiplied times by 3. Actually, we cannot solve this statement, this numerical, without using mass of the sun. So this is what we have to know by ourselves. We have to put this by ourselves, and you can Google it for this number. You can Google what is the mass of the sun. And after that, you can memorize that it is 2 into 10 to the power 3, 30. Yes. Okay, after that, I just explained it that as F is equal to mg and G is equal to F over m. So this is called strength of gravitational field, force per unit mass. Then we will move to the last question of this assignment, which is question number 9. The mass of a satellite is given. Speed of it is 4.3 into 10 to the power 4.3 kilometer per second, and distance is 2.5 into 10 to the power 7. the thing which we have to calculate is the acceleration, which is g obviously, and then we have to calculate the gravitational force on the satellite. Okay, then we have to find the force as well. So because we know that we can simply put F is equal to mg is equal to g m over r square, then we can cancel the m with the small mass and g will become this value. So we know that gravitational constant is 6.67 to 10 power minus 11, and mass of the artificial satellite is given. No, it is not. Okay, this is a satellite other than artificial satellite. So it is given, and the radius, or you can call it the radius plus altitude, is also given, or the distance of the satellite from the earth. We can simply sub the values and get the value of g. Then for finding the second part, we can multiply this value with the mass of the satellite, then we will get force. Or we can also apply this formula, but it will be a little bit more complicated, and the simpler one is to multiply it with mass, because we have the value of gravity. And that's all for all of the questions from this assignment. You got it?